Malay we called it?
Faktor sepunya terbesar. FSTB.
Yes, SSTB, ya, faktor sepunya terbesar. And LCM is?
Gandaan sepunya terkecil GSTK.
Yes, GSTK. Okay, gandaan sepunya terkecil. In case you have studied in Malay, so you can follow us like with these terms. Okay, so today we're going to look at highest common factor and lowest common multiple. Before we continue, we see how do we normally find the highest common factor. Say we want to find the highest common factor for 12 and 20. Okay, so we know what we usually do is we list down the factors for 12. Okay, so factors for 12 will be 1, 2, that means the numbers that is a divisor of 12. 1, 2, 3, 4, 6, and 12. For 20, factors of 20 will be 1, 2, 4, 5, 10, and 20. Okay, so these are factors for both the numbers. So we look at all the common factors. So 1 is a common factor, 2 is a common factor, that means they occur in both 12 and 20, and 4 is a common factor. So we have 3 common factors for 12 and 20. So the highest common factor or HCF for 12 and 20 is 4. 4 is the highest common factor. Okay, so this is how we normally find the highest common factor. But because these two numbers are small numbers, if these two numbers are large numbers, then it will be very difficult for us to list down all the factors. It will take a lot of time. Okay, so maybe there's another way to find the highest common factor. So for lowest common multiple, gandaan sepunya terkecil, that means we're going to find the multiples of each number. Say we want to find the lowest common multiple for 5 and 7. So what we can do is we can list down the multiples. Okay, so we list several multiples first. For 5, the multiples will be 5, 10, 15, 20, 25, 30, 35, and so on. Okay, for 7, we will have, say maybe we list a little bit more. Okay, 40, 45, and so on. Okay, for 7, we will have 7 multiples, gandaan. So 7, 14, 21, 28, 35, 42, 49, and so on. So we want the lowest common multiple, that means the same multiple. So we look at the same multiples here. We can see that the first multiple is 35. And maybe there are other multiples along the way, but we want the lowest common multiple, which is the first common multiple. Okay, so therefore the LCM for 5 and 7 is, for LCM for 5 and 7 is 35. Okay, so you understand this, how to find highest common factor and lowest common multiple. Okay, so because if you look at both the methods, you need to list down the factors for highest common factor, and you also need to list down all the multiples for the lowest common multiple. Okay, this is okay unless the numbers are very big, which is difficult to do. So we need to have a different method to find the highest common factor and the lowest common multiple. Okay, so let's see how we can use prime factorization to find HCF and LCM. Okay, let's look at one example here. Find the HCF and LCM of 60 and 27. So step 1 is to do the prime factorization. Okay. Okay, step 1, we're going to do prime factorization. If you remember, we're going to factorize 60. So 60 we can write it as 10 times 6 or any other 20 times 3, up to you. You can use any number. We'll still end up with the same answers. Okay. So 10 is 2 and 5. 6 is 2 times 3. Now we have all prime factors. So 60 is 2 times 2 times 3 times 5. I'm going to leave it like this. Okay. And then we have the second number, 27. 9 times 3. 9 is 3, 3, and 3. So 27 is 3 times 3 times 3. So all these are prime factors, okay? So now let's see which are the common prime factors here. So we have 3 here and we have 3 here. We have one set of 3, okay? So no other common factors, okay? So step 2, we're going to draw the Venn diagram. Okay, so how are we going to draw the Venn diagram? I'll make it a little bit smaller for you, okay? Okay, we're going to draw the Venn diagram. We have two numbers here, and both the numbers overlap because they have a common factor, okay? So we're going to draw one circle and another circle here, okay? So because these two numbers are overlapping, that means they are in both the numbers, so we put them in the overlapping space here, 3. There's only one number 3, okay? So we label both the circles. This is for 60 and this is for 27. So what other factors are there in 60? We have 2, 2, and 5. So we have 2, 2, and 5. For 27, we have 3 and 3, 3 and 3. Okay, that is step 2. Okay, so step 3 will be to write down our answer. Okay, from here, our HCF is 3, or we can write it like this. This is a good way to write that. Notation is for 60 and 27 is equals to 3. LCM for 60 and 27 is, LCM will be all the other factors other than 3, okay? So LCM is 2 times 2 times 5 times 3 times 3. So how much is this? We know that 2 times 5 is 10. 3 times 3, 9. 9 times 2 is 18. 18 times 10 is 180. Okay, so the LCM, HCF is 3, LCM is 180. Oh, did I multiply correctly? 2 times 2 times 5, 2 times 2 times 5. Oh, sorry, I forgot to multiply one more 3. This 3 also must multiply, yeah, times 3. So 180 times 3. 18 times 3 is 54, so it's 540. So LCM, we multiply all the factors. HCF is only the one in the overlapping space. Okay, so this is how we use prime factorization and Venn diagram to find HCF and LCM. Any questions? Okay, let's do one more example. Okay, use the Venn diagram method to find the HCF and LCM of 240 and 420. Okay, so step 1, do prime factorization. 240, you can use any two numbers. 24 times 10, 24 is 8 times 3, 8 is 2 times 4. Okay, you can bring this down. 4 is 2, 2. So I have 2, 2, 2, 2, 3. 10 is 2 times 5. So I have 2 and 5. So therefore, 240 is 2 times 2 times 2 times 2 times 3 times 10. Is that correct? Okay, 240,
Yes.
correct. Yeah? And then I have 420, which is 42 times 10. No? 420, 42 is 62, 7 times 3 times 5 times 7. Okay, so step 2, I'm going to draw the Venn diagram. So I have two numbers which are overlapping. So this is 240 and this is 420. So what are the numbers that are overlapping? I have two twos here, I have two twos here, I have 1, 3, 1, 3, 1, 5, 1, 5. Okay, so these are the numbers that are overlapping. So I have 2, 2, 3, and 5 in the overlapping space. Okay, so for 240, I have another 2, 2. For 420, there is 7. Okay, so from here, HCF for 240 and 420 is 2 times 2 times 3 times 5. 5 times 2 is 10. So LCM for 240 and 420 is, okay, LCM is 2 times 2 times 2 times 2 times 3 times 5 times 7, everything. Okay, so this is, how much is this? 5 times 2 is 10. Okay, so what else we have? 3 times 2 times 2, 4 times 3 is 12, 12 times 2 is 24, 24 times 7 is how much? Anyone? How much is this?
1680.
80, is it? 80.
Yes.
80 or 18.
080. Yeah.
Correct?
Yeah.
Okay, so this is the LCM. Okay, thanks. So this is the LCM and HCF. Okay, so can do this method? Understand? Any questions?
Understand, madam?
So don't skip. Okay, so don't skip. I know some of you can straight away go to step 2 and do this. Okay, or without step 2 straight away, you can go to, from step 1 you can go to step 3 and get the answer straight away. Okay, but if the question says draw the diagram, you must draw. Okay, even if they tell you, didn't ask you to draw the Venn diagram, you still need to draw and show everything. Okay, so do all the steps. Okay. Okay, let's look at the relationship between HCF and LCM. Okay. Okay, we're going to look at the relationship between the highest common factor, HCF, and the lowest common multiple. Okay, say we have two numbers. Okay, say we have 40 and 24. Okay, and I've already calculated the HCF is 8 and the LCM is 120. So what is the HCM multiplied by the LCM? So which means this is 120 times 8. How much is that? Anyone?
960.
960, yeah?
960.
Did you use a calculator?
Yes.
I hope you didn't use a calculator. 12 times 8 is 96. So numbers. So 40 times 24 is also 960. Okay. So supposing I had another two numbers, we did this just now, 60 and 27. So Okay, so we had another two numbers here just now. We did this 60 and 27. The HCF was 3 and the LCM was 540. So HCM times LCM will give us 1620. Yeah? So if A times B, A is 60 times 27. 60 times 27. If you use your calculator, do you also get 1620?
Yes, madam.
Yes.
Okay, thank you. So suppose I give you one last number here, 420 and 132. So the LCM is 12 and HCF is 12 and LCM is 4620. Yeah? LCM is the multiple. That's why the LCM is always a very large number. Okay. HCM is the common factor, so it's smaller. Okay. So I have this, and HCM times LCM will give me 55,440. A times B, 420 times 132, also 55,440. Okay. So from here, what do you notice? What can you deduce from here? Or what can you infer from here? You see this? And this is always the same value, right? Okay, this and this always the same value. So from here we can say that HCM for A and B, that means for any value of A and B, times LCM for any value of A and B is the same as A times B, correct?
Yes.
Yes. So from here, we can also infer that HCM for A and B is equals to A times B over LCM of AB, right? So this is the relationship between HCM and LCM. HCM is A multiplied by B divided by the LCM, or LCM is A multiplied by B divided by HCF. Okay, class? Can understand the relationship between HCF and LCM? Yes?
Yes.
Yes,
Yes,
madam.
madam.
Okay. Okay, so let's try one question first before we move on. Okay, this is a problem solving question, okay, for this topic. So I'm thinking of two numbers. The highest common factor of my two numbers is 10 and the LCM of my two numbers is 300. What are my two numbers? So let's say I will assume, okay? Assume that the two numbers are x and y, okay? So you have two numbers, x and y. So it's given here that HCF of x, y is 10 and LCM of x, y is 300, okay? So how are we going to find the two numbers? Can you try first and then let me know what are the two numbers? I give you 5 minutes to try, not 5 minutes, a few minutes. So you have an answer? Anybody has an answer? No? Okay. Okay, so let's just look at this relationship first, okay? We know the HCF is 10 and LCM is 300. So HCF is 10, A times B, LCM is 300. Therefore, A times B is 10 times 300, which is 3000. This is just for us to confirm, okay? Later we want to confirm the answer is correct. So we know that the two we use, in this case, we can use x times y because we have said our two numbers are x and y, okay? So we write here, it doesn't matter what alphabet you use, but be consistent. X times y, x times y. So we know that our two numbers, x times y, must give us 3000. From this relationship, we have known that, okay? So now we look. We are given that HCF is 10. So let's try to break down HCF and do the prime factorization. We have 2 and 5, okay? This is our HCF is 10. And then we have LCM is 300, okay? 300 is 30. Let's do prime factorization. 30 times 10. 30 will be 10 times 3. This is 2 and 5. This is 2 and 5. Okay, so this is our HCF and LCM. Okay, so HCF is 2 times 5. LCM is 2 times 2 times 3 times 5 times 5. Correct? Okay, so let's look at the common factors here is 2, 5, 2, and 5. Okay, so if we drew our Venn diagram, so our common factors will be here 2 and 5. Let's say this is x and this is y. Okay, so x will be this and y will be, maybe we can put here 2, 3, and 5. Correct? Is that correct?
Yes.
So what
Yes.
is x and what is y? So if we do like this, so our x is, what's our x value?
10.
10, right? What's our y value?
50.
Again, why
30.
is this 30? Y is,
300.
300.
yes, 300. Huh? So just now we found that x times y must give us 3000. So does x times y give us 3000? Yes? Yes. So this is
Yes.
correct. Is there any other choices? Is there any other possible values for x and y? Yes, isn't it? Okay, we can also do our Venn diagram like this, 2, 4. It all depends on where we place this 2, 3, 5. If we put our 2 here and 3, 5, now our 3, 5 here, now our x is
20.
20, y will be
150.
150.
150.
Correct. Does this give us 3000? Yes. Is there any other possibility?
Yes.
What's the other possibility? These 2 and 5, they can't change. What else can we do? Whether, because they asked us what are the two numbers, they didn't say, oh, we ourselves put x and y, okay? So this and this is still the same, okay? This and this is still the same, okay? So we don't need to do that. So what are the other possibilities? Can we put 2, 3 here and 5 here? So what is x now?
60.
60 and y is
50.
50. So we have 3000. What other, is there any other possibility? Is there any other? There's maybe one more. So this is 2, 5. We can have 3 and we can have 2 and 5 here, right? So x will be 30 and y will be 100. Also 3000. Okay. Is there any other possibility? Okay, I think that's about it. Okay. So x can be 10 and y can be 300, or x can be 20 and y can be 150, or x can be 60 and y can be 50, or x can be 30 and y can be 100. So these are the four possible numbers for your two numbers. So finally our answer, you need to write it down. What are my two numbers? Okay, so my two numbers are 10 and 300, or 10 and 300, or 20 and 150, or 60 and 50, or 30 and 100. Okay, so there are so many possibilities. So when you do this kind of problem solving question, you must look into all the aspects. You must see whether there are other combinations possible or not. Okay, any questions regarding this question? So when you answer questions like this, don't just give the calculation. Okay, you can give a lot of explanation in words as well. Okay, it will really help. Okay, so we have finished with HCF and LCM. Okay, so next we're going to look at Goldbach's conjecture. Okay, Goldbach's conjecture. Do you know what's a conjecture? A conjecture is a true statement but hasn't been proven yet. Okay, so in 1742, the mathematician Christian Goldbach observed that every even number seemed representable as the sum of two primes. In other words, every even number, you can write it as the sum of two primes. Okay, for example, 4 equals to 2 plus 2. 2 is a prime number, so we have written 4 as an even number. So even number can be written as a sum of two prime numbers. So Goldbach, he could not prove this result, So what he did was he wrote to his friend, the world famous mathematician, Leonhard Euler. Okay, if you've read about the history of mathematics, you know that Euler was a very famous mathematician. Okay, so Euler was his good friend, and he also couldn't prove and he couldn't disprove the conjecture. So until today, this problem remains unsolved. That's why it is known as Goldbach's conjecture, because until today, it has not been proven to be right or wrong. Okay, so that's why it's a very interesting problem. Okay, so for example, write the following numbers as a sum of two primes. Okay, let's see if we can write 16 as a sum of two primes. How would we write this as a sum of two primes? 16 is, anybody?
13 plus 3.
13 plus 3. Okay, good. 13 plus 3. Both of these are prime numbers. Any other combinations?
11 plus 5.
Right, 11 plus 5. Okay, so how about 10? 10, we can write this as
5 plus 5.
5 plus 5.
7 plus
Any
3.
7 plus 3. Any more?
6 plus 4.
6 plus 4. Okay, 6 is not a prime number. Okay, so we are only writing this as a combination of prime number. Okay, so Goldbach says that every even number, you can write it as a sum of two primes. So only prime numbers. Okay, this is the conjecture. Okay, so let's look at another example. 48. Can we write this as a sum of two primes? Anyone want to try? Is 1 a prime number? Anyone? Is 1 a prime number? Okay, it's not. It's not. 1 is not a prime number, so we cannot start with 1. Okay?
Madam,
Yeah?
how about 41 plus 7?
Yes. 41 plus 7, both prime numbers. Okay, so it's correct. Any other combinations? There are at least two more that I can think of.
43 plus 5.
43 plus 5. Yes, 43 plus 5, both prime numbers.
37 plus 11.
37 plus 11. Yes, 37 plus 11. 17 plus 31. 19 plus 29. Okay, so there's sometimes, so you may be asked to list down all the prime numbers. So you start working from 2 and go 2 can plus with what? 2 plus 46, so cannot. So then 3 plus, what's the next number? And you have to work it out systematically lah. So as long as both the numbers are primes, then it's following Goldbach's conjecture. Okay, so that's quite simple, right? Okay, so we have finished with Goldbach's conjecture, that's all. Okay, okay, now we're going on to Euclidean algorithm. Okay, Euclidean algorithm. Euclidean algorithm or Euclid's algorithm is an efficient method for computing the greatest common divisor of two integers. Okay, in other words, it is the largest number that divides them both without a remainder, also known as the highest common factor. Okay, so example. Okay, before you do that, you need to know the two terms. Okay. Okay, when you divide a number, okay, the number inside here is known as the dividend. Okay, the number outside here is the divisor, and your answer is the quotient. Okay, so this is dividend, and what's outside here is the divisor. Okay, so when you want to find the greatest common divisor of 123 and 36, we have to this becomes the dividend. The first number is the dividend and the second number is the divisor. So 123 divided by 36. So what do we get? 36 times 12 cannot. So 120. How many 36 is 123? So we have 3 here, which gives us 108. So remainder of 15, correct? Okay, I'm going to write here remainder 15 here, so that, okay, so for the next step, what will happen is this 15 will come here. Okay, the 15 will be the new divisor, 36 will become the dividend. Okay, so you think of it like 15, you write here and push the 36 inside. Okay, so for the next step, we have 36 here and 15 here. So 36 divided by 15 is 2. 2 times 15 is 30, remainder 6. Okay, remainder 6. So what happens is the 6 will come here and push the 15 inside. So you have 15 here and 6. 6 times 2 is 12, remainder 3. So remainder 3. So the 3 will come here outside and 6 goes inside. Okay, so 6 divided by 3, 6 times 2 is 6. 0. When you reach 0, you stop. And your answer is the last divisor. Okay? So therefore, GCD of 123 and 36 is 3. That means the greatest common divisor for these two numbers is 3. Or in other words, the highest common factor for these two numbers is 3. Can understand?
Can.
Okay, let's do another example. Okay, find the GCD for 524 and 148. First step is 524 divided by 148. Okay, so how much is this? 148 times
3,
3. How much is that?
4, 4, 4.
So remainder
80.
80.
80. So what do I write in the next step? What is inside here?
148.
148.
Divisor is
80.
80.
80. Yes. So if you write here like this, is you remember easier. Okay. So 80. How many times 80 is 148?
1.
1. So minus 80. What's the remainder?
68.
68. So next step here. What's inside?
6,
80
3,
divided by
68.
68.
8. So I have 168 here. Remainder is 12. We keep on doing until we reach 0, okay? So this is 68 divided by 12. 12 times 5, 60. So we have 8 here. And then we have 12 divided by 8 is 1. 8 is 4. Okay? So which means we have to do one more. So 8 divided by 4 is 280. So we reach 0. So when we reach 0, the last divisor is our answer. Therefore, GCD for 524 and 148 is 4. Okay? Can you understand?
Understand.
Okay. What's
Yes.
the purpose of this GCD? Why do we need to calculate GCD? What's the purpose of this Euclidean algorithm? Okay. So one use for Euclidean algorithm is that it's very useful for reducing a common fraction to its lowest terms. Okay. See, you're given this number here, and say you did some calculation and you arrived at this number, and they asked you to give the answer at the lowest term or simplest form. Okay, so now you want to divide this, so you don't know how to reduce it. Okay, so the best thing is you can use GCD. Okay, find the GCD for these two numbers. Okay, okay, what will the GCD be? Let's do it on the side here. Okay, so 765 divided by 714. How many times is that? 1, right? So
1.
714 minus, what do we get? 51. So now, what's inside here? 714
7,
divided by 51.
51.
So how many times 51 can go into 714? 14 times 714, we have 0. So 51 is the greatest common divisor. The greatest. So when you want to reduce a number, you want to divide it by the greatest common. Straight away, divide by the greatest common divisor. So that is the, you can't reduce it anymore after that. Okay, so you would get 15 over 14, which is 1 over 14, or you can leave it as that. If you want to just simplify the fraction, we leave it as this. Okay, so that is the purpose of the greatest common, the Euclidean algorithm. It helps us to reduce fractions very quickly. Okay, if you want to find factors by yourself one by one and try to first divide by 2, then divide by 3, by 5, and then it will take a long time. But you do this way, you get your answer very quickly. Okay, let's try one more example for reducing fractions. Okay, so reduce the fraction 861 and 984 to the lowest term. So how do we do this? 861 divided by 98. Sorry, we always divide the bigger number and the smaller number. So 984 divided by 86. 1. Okay, so we have 1861 minus we have 123. Okay, so 123 becomes the new divisor. We have 861 here, 123 times 7, 8610. So our G, so you come here, you know that the GCD for 861 and 984 is 123. That means both the numbers can be divided by 123, and that's the greatest common divisor. To simplify this, we divide both with 123. 984 divided by 123, we get 7 over 8. Okay, so we have reduced this fraction very fast by using GCD method. Okay, so using Euclidean algorithms to reduce fraction, that's one of the purpose of the Euclidean algorithm. Okay, 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 I have one last problem solving question. Okay, yeah. This is a problem solving question. Okay, so you need to use what you have learned earlier. Okay, a machine has 3 interlocking gears with 76, 24, and 42 teeth respectively, something like this. These are called gears. Okay, so what is the fewest number of revolution? We want the fewest, the least, lowest number of revolution that the large gear has to make in order for the 3 gears to return to their original position together. So what are we going to use to find this? Which concept? Okay, let me just explain this a little bit. So one revolution of any gear, one revolution is one whole cycle, one pusingan, okay? One cycle of this gear is equivalent to all the teeth of the gear passing by the initial starting point. If say this is your initial starting point and this gear say has 76 teeth, then all 76 teeth must pass through X. Okay, that is called one revolution. Second revolution is when again all the 76 teeth pass through X. That will be the second revolution. That means it's 2 times 76. Third revolution will be 3 times 76. Okay, so any multiple of the number of teeth therefore brings the gear back to its starting point. Okay, for all the gears to return to the starting point at the same time, the number of teeth that have passed by must be a common multiple of 76, 24, and 42. Okay, so if you found the LCM of 26, so you need to find the LCM of 76, 24, and 42 for you to know the fewest number of revolution that the large gear has to make in order for the 3 gears to return to their original position. Okay.